So in today's video, I'm going to be looking at recursion. So what is recursion? Recursion, or a recursive function, is a function that calls itself in most cases, because in some cases it might call other functions which go back to itself, until a certain base case is reached. So the base case is the case that stops the function from calling itself and then returns back to all the calls, or returns back to all the calls that the function called to itself. So let's look at a quick example. It asks us write a recursive function for the following: the factorial function. So let's look at an example just of a recursive function. So if I, for example, of factorials. So if I have 5 factorial, then that would mean 5 times 4 times 3 times 2 times 1. So how can I break this up? Well, let's have a look. If I have 5 times 4 factorial, that's the same as saying 5 factorial. I can also break this 4 factorial up into 4 times 3 factorial. And I can break the 3 factorial up into 3 times 2 factorial. And I can break the 2 factorial up into 2 times 1 factorial, which is just 1. In which case it would just return back there, and back there. So how can I write a function for this? Well, let's see. Let's call it int fact for factorial. And it's going to take an integer n, for which it has to find the factorial. So let's see. If we have a look at what we wrote here, then it looks like we start returning when we have 1 left, because then the factorial sign vanishes and we just have 1 left. So it looks like our base case would be if n equal to 0 or 1, maybe. So let's see, if n equals 0, 0 factorial, by the way, is also 1. So then we return 1. Else, what do we want to do? Well, let's have a look. Else return. If we look at what we're returning, every time we're returning the number that we're at times the factorial of the previous number. So we're saying return n times factorial of n minus 1, like that. Okay, so that's exactly what this is going to do. So it's going to say, okay, n, which is the value we brought in, times the factorial of the n minus 1th one. So every time you're going to call the function with one smaller value. So if this is 5, then this is going to be 4. Then we're going to send in 4 over here, like we did here. And then we're going to do 3 factorial in the next call, because we can say, is n equal to 0? No. Else return 4 times 3 factorial. Then it's going to send 3 into the top here. Excuse me. It's going to send 3 into the top. And then we're going to do 3 times 2 factorial, or factorial of 2. And it's going to send in 2. And then we're going to have 2 times 1 factorial. And eventually it's going to be 0. Okay. So now we also get different types of recursion, one of which is tail recursion. So what does this mean? This means that there's one recursive call at the end of the function. So recursion takes place at the end of the function. So let's write a quick example of that. So for example, void tail, and it takes in some integer z, and we say if z, for example, is greater than 0, then we're going to say system. I'm just going to print something, println, and I keep running out of space, z plus maybe a space, and then we say tail of z minus 1. So all we're doing is we're saying if z is greater than 0, then print it out, and then call it with 1 smaller. So if I send in 4, then the next call will be 3, 2, 1. So you're basically going to see, if you send in 4, then you're going to see printed out 4, 3, 2, 1. And it's just only strictly greater than 0. Okay. Non-tail recursion is a recursive call not at the end of the function. So let's write an example of that. Void non-tail, because it's not tail recursion. Ha! Int z, and we say if z is greater than 0 again, then we're going to say non-tail of z, and system dot out dot println z plus white space. Okay, so what is different between these two? Well, in the one you're printing out first the value, and then you're doing the call to the recursive call to the function. And then this one, you're first doing the recursive call. So you're going to go through all the recursive calls first, and then come back and print them out. So it's going to be printed out the other way around. So your printed will instead be, so you're going to say, okay, well, recursive call of, let's say, 3. Then you're going to do a non-tail recursive call of z minus 1. This is supposed to be z minus 1. My apologies. Then you're going to do a call with 2, and then 1, and then it's going to be 0, and it's going to return the call, but it's going to go back to the first return call. So it's going to print out 1, 2, and then 3. Because the recursive call with 1 was the last recursive call we did that returned a value. And it's going to return 1, it's going to return 2, and it's going to return 3. Okay, indirect recursion is a function call when a function calls other functions which recurs back to the original function. Okay, so an example of that is, let's say, go to the opera. So go to opera. Okay, so what do you have to do to go to the opera? You have to drive to the opera. So let's use another color. So drive. So when you drive to the opera, what do you do then? Well, then you're going to watch the opera. And after you've watched it, you're going to go home. Or you're going to, go home. Go home. And after you've gone home, well, you're going to wait 1 year for the next one. So wait. Well, wait 1 year. And after you've waited 1 year, then you're going to go to the opera again. Go to opera. So what are you going to do? You're going to go to the opera. You're going to drive there. Then you're going to watch it. And after you've watched it, you're going to go home. And after you've gone home, you're going to wait 1 year. After you've waited 1 year, you're going to go to the opera again. So that's indirect recursion because we're calling other functions from this function. And then it just goes back to that original function again. Okay. After that example, you'll never forget it. Nested recursion. So this is recursion inside recursion. So let's have a look at that. So if I call it int nested int z, So if z is less than or equal to 0, return 0. That is our base case. Else, if z is greater than 10 and z is less than 30, return z. Else, return nested. Let's just do this to make it more clear. Nested of 1 plus nested, let's say 2 times z. So there is your nested call. So there's your base case, z less than or equal to 0. Also, if z is greater than 10 or less than 30, then you just return the number z. Else, you return nested, we're calling nested, 1 plus, and then this is a call to nested within a call to nested. That makes it a nested recursion.